All right, welcome to the Summer Institute for Computational Social Science, sponsored by Howard and Mathematica and held at Howard University. We're here to talk to you about programming in R for application to social science research. My name is Evan Muzzall, and I'll be your lecturer this weekend. I am head of software and services for data science at the Cecil H. Green Library at Stanford University. I'm joined today by Jose Aveldanes, a fourth-year Ph.D. student at UC Berkeley in sociology, and Jose will monitor the chat and will be the quickest way to get your questions answered if you type them there. However, feel free to unmute yourself and interrupt me also. And really, please ask us anything from installation issues to syntax questions and broader questions about research. Okay, so these workshop materials, I'll put these in the chat, and these are found on GitHub. If you guys want to learn about GitHub, please reach out to me or Jose. And well, that's the schedule. And if you're a budding data science, if you're a novice or intermediate or advanced, GitHub is definitely something that you want to get on your radar. It's essentially a version tracking program for code, and it's great for keeping track of your projects and for collaboration. So we won't be able to cover everything under the sun. We have 6 hours together, 3 today, and then we meet tomorrow, I believe a half hour earlier from 2 to 5 p.m. Eastern time. So please refer back to these materials as needed. Try to make the connections in your brain in a way that makes sense to you. Keep a list of questions, and you can reach out to me at the email address provided here. All right, so everybody go ahead and visit this page, and we'll just cover some front matter, and we'll get into the code here in the next 5 or 10 minutes. So, please do reach out if you want to talk about machine learning, if you want to talk about text analysis or making a personal or a project website using GitHub or some other software. We're here to support. So hopefully this is not our only interaction. Okay, so our workshop goals are really to introduce you to a variety of computational methods in R for confident and responsible application to your own research. If you're a beginner, you're going to learn how R fits into a basic computational social science workflow. And if you're already an R user, we hope to help you structure your R foundation and maybe even teach you a thing or two you didn't know. If you are more intermediate or advanced as we go along, please feel free to chime in with your perspective, with your experiences. And that goes for the beginners as well. So we want to make this as engaging as possible for you all. Okay, so the data sets we're going to use, we're going to look at some data from the Stanford Open Policing Project. So this is traffic stop data by state. We'll use a Gapminder data set. Gapminder is a nonprofit institute from Sweden, founded by the late Hans Wrangling, and a Midwest graphics data set, demographic data set, and some others to keep you kind of on your toes and throw a few curveballs at you here and there. Okay, so these materials are organized in the following way. Basically, these files here. We're most interested today in the part1.rmd file. This is an R markdown file, and this is going to contain the code and the text that we are going to walk through today. If you want to, the HTML file also contains some documents that contain the exact same thing that the R markdown files contain, except it looks nice in your web browser. Okay, so today we're going to go through kind of these introductions and these installations. We're going to talk about a basic computational social science research workflow. We'll talk about R and RStudio, your inputs, your source files, kind of what's the difference between an R script and what Markdown is. And we'll talk about navigating RStudio. So we're going to use the RStudio environment to program R. R is the programming language that we're going to use. And then we'll really get into the basic building blocks of R programming. All right, we'll take a break halfway through, and then we'll kind of put everything together into a basic workflow example for the last hour or so, and end with talking about how you save your work. Okay, and then Tomorrow is really going to be the deep dives. So today we're going to kind of give you an overview of the whole process. And then tomorrow we're going to do some deep dives into data reshaping, data wrangling, data visualization, and statistical modeling. So if you have not done so already, please visit these two links to download R and RStudio. So what is R? Well, R is a programming language, and it's really evolved for completing data science tasks. It's very much a statistical language, although it can do other things. And a programming language is really just a way to give instructions to a computer. You don't have to think about it in any more complex terms than that. So R is the language, RStudio is the environment in which we will program R. And RStudio gives us a bunch of enhanced functionality that we would not have if we just used R alone. Okay, if you're having local install issues, again, please type your questions in the chat. Jose will answer those as quickly as he can, or feel free to interrupt myself. If you want to, you can right-click this launch binder badge here and open up a cloud-based version of RStudio in your preferred web browser. And this contains all the exact same materials that we're going through locally here in this GitHub repository. Okay, so how do you download these workshop materials? First, visit this link again. Let me put this in the chat once more, just in case you're joining us. And click the green code button here up at the top. And click download zip. And then extract these files someplace familiar. I always recommend the desktop. If you're on Mac, I think you can double click the zip file, and the archive tool will automatically extract it. If you're on Windows, I think you have to right click it and say extract here, or WinZip extract here, or 7-zip extract here. And if you're a Git user, you can simply git clone this repository. And if you're successful, you want to open up part 1 RMD, and that's going to look something like this here. So take a few minutes. And as I always tell people, if you are crying and tearing your hair out, you're doing it correctly. So learning to program is very much like a sine curve type of thing. One day you feel like you got a handle on things, and the next day it feels frustrating and you want to quit. That's normal. And I tell people, you know, give it 6 months, give it 3 months, and you'll know kind of where you stand. It's hard to judge. If you're a beginner, it's really hard to judge what it's like in the beginning because it feels so overwhelming. But again, please email me anytime. I'm happy to support you guys over the course of the next couple months throughout the summer. So
I just want to echo what Evan is saying. It took me a really long time to become comfortable with coding. I actually remember being an undergrad and seeing a line of Stata code or like a do file and being like, I need a new career. I can't be a sociologist. I need to do something else. So it does get better over time.
yeah, well said, Jose. And really, you know, the more you know, the more complex your questions become. So I don't know if any of you are, you know, I really like to compare programming to art. I really like trying to tap into people's creative nature, where maybe a script or something is like your blank canvas. I love to play music, and it's like, well, there's really no end to it. You know, the better you get at playing music, you know, how do you switch up the voicings? How do you stretch your pinky on the guitar fretboard or the piano to hit a note that maybe you couldn't hit when you were just starting out? How do you arrange the notes in a different way, the progressions of the chords, right? How do you flip them around? And that's kind of the essence of programming, right? How do you come up with something creative to solve a problem? It's really all about problem solving. Okay, so again, you should have a folder on your computer like this if you're successful. And in the HTML file, you can open up the part 1 HTML and see something like this. So this is an interactive HTML file that was generated from the R Markdown file. So you can really create sort of interactive presentations. You can export to PDF and Word documents. You can use Markdown to make a personal website if you want on GitHub pages. You can make slideshows. There's just a lot that you can do. And then tomorrow, we'll get into a lot more interesting things in terms of data wrangling, data visualization, customizations. But today we really want to give you a nice overview of what the research process looks like. So let us know, type the name of your favorite beverage in the chat or give us an emoji if you are ready to go. Sure, no problem. All right, so Andrea, were you able to click code and download zip?
Yes, I did that, and I looked in my zip file and I clicked on what I thought was right, but I didn't see that document that you just showed. It just took me to RStudio.
Okay, yeah, so the first step is to actually extract that file. Are you on Windows or Mac?
Windows.
Okay, so if you look in your downloads folder, we're looking for this zip file, and you want to actually right-click that. And there should be an option that says like 7-zip and then extract all. Try that.
So I have our 2002 master. That's what I got. And then and then I click on that, and then I have the list that's similar. But when I go to part 1, it takes me to RStudio.
Yeah, so if I understand correctly, you want to right-click it and you want to extract this file first.
Okay. All right. Thank you.
Yep, you're welcome. Yep. Yeah, this is what it's like, you guys. It's like, you know, asking for help can feel intimidating, but we're here to support you guys throughout the course of the summer as well. So anybody else?
Yeah, I downloaded R, but for some reason, like I'm typing it in to find it, and I see it's popping up in my it's saying RStudio, but double clicking, and I was able to open it recently, double clicking on it, but it's not opening up.
But it's not opening up. Okay, and is that R or RStudio?
RStudio.
Okay. Let's see here.
The only thing I did most recently, because I need to fix my computer, is I moved over all the downloads to another folder in my computer. So I don't know if that changed something.
Yeah, it could have. So try to visit this link here and just try once more. Maybe the executable file got moved along with the rest of the files that you moved. Maybe try once more.
Oh, I think it might be doing it now.
Okay.
Thank you.
Yeah, you're welcome. Yeah, so again, you know, if the programming isn't hard enough, it's just like, oh my gosh, managing all this software and trying to figure out where things are on your computer can be a challenge as well. Anybody else, please? We're good for time. We want to make sure you feel empowered to be successful here the next couple of days. And maybe what you want to do as well is also open up this binder link here. So right click it and say open a new tab. And that'll launch a cloud-based version as well in case you're having any local install issues. And it should just take a minute or two to load up.
So I'm just saying that I'm lost again, so I'm gonna try it one more time.
Sure. Yeah, and Jose, if you wanna direct message Andrea, or
You got it.
cool. So we'll take it slow here in the beginning. We won't jump into RStudio quite yet. Yeah, so Erica, in this case, since I set up the binder environment, it's not on your account per se. It's actually through my GitHub profile here. But you can still work and save files when you make changes here. For example, if we open a new script, which we'll talk about how to do momentarily, and add a variable or something. When I save this, I can only save it to this instance of binder, and maybe I call this test, right? So then we see test here appear. What you can do is check this box, and then under the more tab here, you can click export and actually save that to your computer. And again, if you want to learn more about starting up binder environments, please reach out. I'm more than happy to chat offline. Does that make sense?
Yes, thank you.
Yeah, you're welcome. Okay, so as we kind of handle installation issues and get started, let's just talk about an example computational social science research workflow. And one of the main problems facing higher education at the moment, I mean, there's a lot of them, but one of the main ones between faculty and students, and the reason that we are here in higher education, is that there's an assumption that students know how to do research. But nobody maybe has taken the time to show them. So there's this sort of gap in mentorship that computational tools can sort of fill if you can learn your way around tools like R and how to be a self-learner a little bit. Okay, so it's like, well, you know, you're expected to know how to do research, but you've never had the opportunity to do so. So really one of the ways to kind of crack that shell is to kind of understand the process. And no matter what project I approach, I kind of take this same sort of framework, even if the data are different, even if the questions are different. But this is my sort of general basic approach to research. So scientific research is necessary because it provides solutions to many problems, from those found in everyday life to the mysteries of existence. We use research to build knowledge, to teach, to learn, and to increase awareness through cutting-edge technologies and techniques that create new ideas and that are born out of creativity and curiosity. Again, we'll talk about, you know, tapping your creative potential here as we go along. Social science research focuses on humans, their interactions, and the societies that they exist within, and relies on data, forms of information, for research to work. And for all intents and purposes, we're just concerned about definitions of data that refer to quantitative or qualitative variables. All right, so how do you approach a research project? Well, the most foundational step is to read the relevant literature in your field. It's difficult to determine what is relevant, but with some practice, you can kind of figure out, well, what are you interested in? Who's writing about those topics? And how can you sort of tailor them to fit your interests? And really focus on those discussion sections, right? What are authors saying? Where should research go? What are the problems and limitations that they're facing? So if you do this for a couple of articles, if you read a few articles, you can kind of cobble together research questions, new and old alike, that essentially can help push your discipline into new and relevant directions. So from there, you can kind of ask these questions, right? Well, 5 different authors are talking about sort of the same topic. So you can use your sort of creative potential to say, well, I'm going to ask a question in this way and try to find a data set that allows me to test these assumptions, and I can examine my expectations for the outcomes of the research. So you can kind of design the rest of this, the red, the yellow, the green, and the blue parts in this early stage as well. If you want to make research reproducible, that's something that you want to bake in very early on. A lot of people come to me in a consultation capacity and they're finishing up a project and they say, I want to make it reproducible. And that's very challenging to do when a project is nearing completion because there's so many different steps that you have to include and that should be included from this sort of design phase. And then really, talk about your milestones. How can you divide your research project up into a bunch of subsections, not only so you can feel a sense of progress, but so you can also really understand how the parts connect in more relevant ways. Sorry, was there a question?
Oh, could I just say something really
Yeah, please,
quick?
please.
So I just wanted to make it sort of explicit to folks that so Evan's working from the binder, and there's two ways that you can sort of access all of these materials. You could either launch the binder that's in the GitHub page. So if you go to the GitHub page, there is a link that says launch binder. Click here to launch binder. That will just open up the RStudio interface in a web browser and will have all the materials that you need. Alternatively, you could download all of those materials and do it locally on your local machine. So there's two ways to do this and follow along. And then if you're trying to find the part one, like HTML, there's an HTML folder in the materials, and then you just open that in a web browser and you should be good to go. That was a lot of information, so please let me know if I went too fast, but I just wanted to make that clear because that can be confusing.
Yeah, thank you, Jose. And please, interrupt if something is not making sense, if you missed a step earlier. This is all about your learning and your growth, and this is totally fine if you have questions. So be persistent in asking for help. Yep, so I'm in the part one HTML file. Here. And this contains the exact same information that's found in the R Markdown part one and the binder part one as well. Okay, so really, try to identify what sort of data sets are you looking for? Who can help you find the data? Do you have to scrape it from the web? Can somebody at the library help you? Or maybe somebody in your cohort or your lab group can help you out. So, start thinking about data as well. Yeah, so Jose says, let's get a +1 in the chat if everyone's on the same page here. All right. Yeah, Jose, could you direct message Andrea? Right, so there's all this work that has to be done before you even get to the sort of data part or the computational part, right? So you have to acquire data somehow. Like I said, you scrape it from the web. Do you find it in the library? Do you ask a professor in your department, and so on and so forth? Only then, right, do we kind of enter with R here, right, at this data import stage. And from there, we want to wrangle the data, which could mean a variety of different things. You'll often hear about data cleaning, right? So maybe we have to standardize a bunch of names. We want to deduplicate entries. We want to look for syntax errors, code missing values, and things of that nature. A little bit of which we'll talk about today, but we'll talk a lot about tomorrow. So from there, once you kind of design your research, you get some data, you import it, and you clean it up. That's like a huge time commitment right there. From there, you can start exploring your data. And really, these sort of exploration and analysis stages, sometimes they're flipped, but I like to do the exploration first to get an idea of, implicit or explicit relationships between variables or between groups. And sometimes, basic summary statistics are really all you need as a sort of guide into what should be visualized and tested. So you don't always need super complex models or AI to produce meaningful results. Sometimes basic summaries can really offer powerful insights into the data. From there, data visualization is a huge component of research, and the idea is to represent aspects of your data in a simple way that can be understood by your audience, whether you're talking to the general public or to other professionals. How can you kind of distill some very complex ideas from data into a visual form that can be the focus of a discussion about its importance? So one book that I really want to get on your guys' radar that's linked on the GitHub page here is this Wilkie book, Fundamentals of Data Visualization. And this is, there's no coding in this book here, but it's really kind of a language agnostic book that talks about theory and best practices for data visualization. So how do you visualize amounts, right? You could use these options. How do you visualize distributions? You could use these options. How do you visualize proportions? You could use these options, and so on and so forth. How do you understand coordinate systems and axes? How do you understand the use of color as a tool to distinguish, as a tool to represent data values, as a tool to highlight, and so on and so forth? So yeah, Susanna, so if I'm not mistaken here, so I recommend the Ggplot2 book here, and I'll put that in the chat for you as well. So this is by Hadley Wickham, the guy that wrote Ggplot2, and we'll talk about a little bit today, but a lot tomorrow. There's some nice copy paste code for you. Yeah, thanks, Jose. Please check out the link Jose is putting in the chat right now as well. Yep, the crab book. Okay, so from there, you kind of have a understanding of how your research is designed, the milestones you have to hit, what are the different parts, when do you need to have that, that third-year prospectus written for your committee, when do you have to write your first and second year papers, how do you build on them to kind of, write your thesis or your dissertation and combine a bunch of parts into something that is greater than, the whole, right? And this is how people kind of get different presentations or publications out of their dissertation, right? Because it's kind of done piecemeal, and then you're putting them together to write the final thing. So for the analysis step right now, we're talking about, well, how do you analyze your data? Is it a t-test? Are you doing means comparisons? Is it a one-way ANOVA or a linear regression? Do you need computational text analysis or machine learning or deep learning? Are your data, maybe your data are audio or images, right? So we should never be sort of beholden to particular statistical tests. It's the data that get to decide along with the questions that we ask. All right, and then, writing is an iterative process. So try to write often, annotate everything you read, get those bad iterations of your drafts out of the way early, and just keep writing. Just keep writing. Write your ideas down. Keep a journal, keep a drive folder or something, and keep I'll keep writing. Okay, so that's kind of my spiel about the overall research process. Now let's go put this into practice. So if you want to open up your RStudio in that part 1 markdown file, we can jump into the R side of things. And maybe this visualization here will be handy, I guess, for the last thing. But essentially, we have 4 window panes here, right? Upper left, lower left, upper right, and lower right. And this is the environment in which we can code R. Okay, so check out the green boxes here for the upper left pane. This is our markdown file or our script. And this is our input. So if you're taking notes, just keep an eye that the one in the upper left is the script. If you only see 3 window panes like this, maybe click your Files tab here, and then click Part 1 RMD, and you should see the 4th appear. So take a moment and just make sure that you can open up Part 1.RMD. Let's pause for questions here. So we talk about a little bit about the workflow, right? You want to read, kind of cobble together a question based on what other authors are saying and or what interests you. Define some milestones, right? What's your timeline? Find some data, import and wrangle that data, explore the data, analyze it, and kind of be writing throughout. Yeah, and we're kind of working up to this, but note the Files tab here in the lower right window pane. Here you can navigate your file structure. And we want SICSS-Howard Mathematica R 2022. And then if you click that Part 1 RMD, it should open up automatically. All right, if it's not there, make sure if you are on Mac, make sure you have the zip file here if you're doing this locally. And you can right click it and say open with archive utility, or simply double click it to actually open the file folder. If you're on Windows, you want to right click it, and I think there's an option that says 7-zip, and then you want to say extract all here. So remember, if you're crying and tearing your hair out, you're doing it correctly. And as Jose said, this is something we've all been through. I think it took me like a year or two to understand how to import data, like over a decade ago. And then you should be able to do the same thing with part2.rmd or the solutions.rmd file. Even if you click install.r, you should see the same thing, but they should open up here in this upper left portion. This install.r file, by the way, just tells Binder what packages to load. We'll talk about packages in a little bit here. Same thing with runtime.txt. That won't open in RStudio. That'll open in your text edit program, and that just tells Binder what version of R should be loaded. But again, these are all things I'm happy to chat offline. Okay, so let's go through some of these. In the top left here, you can click the disk to save your work just like you would in Microsoft Word or something. Alternatively, you can press Control S on Windows or Command S on Mac, or click File, Save, or Save As. But remember, this script, this is your input. So these are the instructions we're going to give R in chronological order to accomplish our data science tasks. Okay, Markdown itself is a text language, so we can enter text normally just by typing. This is the YAML header here. So this is just a special header where I can basically program in what this table of contents should look like here. And we can specify different level headers with hashtags here outside of code chunks. We can insert images, like this is the workflow image that you see here. And then code should be entered in what are called chunks. All right, so chunks are special sections of the Markdown file. Well, basically, we're providing 3 backticks and an R in curly braces to instantiate the code chunk, and then 3 backticks to close it. And inside of that code chunk, we can enter our code. So our data science instructions for R. And there's a few links in here to learn more about our Markdown. Again, we'll give you guys a ton of resources to work through and kind of bookmark. Right, this might take you 6 months to get to, but we want to get it on your radar now. Same thing with code chunks here. How do code chunks work? And if this is all too confusing, you can simply click File, New File, and R script to open up a blank R script. This is just a text file with a .r extension. And we can say, what's 2 plus 2? And then press Control Enter to execute the code. And the output appears down here in the console.
So Evan, can I just clarify something really quick about the setup of R?
Sure.
So in RStudio, you have the console, you have your notebook, RMD files, and you have your environment and files on the right-hand side. So the studio, the part of Evan's screen where you see code on the top left-hand side, that's where your notebook is opening up. So when you open up part1.rmd, that will show up and it will have all the code that you need to follow along. The console you can think of as like the it's the computer person. It's like computing everything. Like if you want to compute basic arithmetic or you're running a model, that's sort of where it happens. Evan, correct me if I'm saying anything that's erroneous. And then the global environment is where everything is stored. So if you're loading in a data set, for example, it'll show up in your global environment after you've assigned it a certain name. If you have a certain function, it'll show up there. Anything of that ilk will show up in the global environment. And then on the very bottom right-hand side are all your files. So it's kind of like the Finder system in your computer where you have, you know, oh, this is where I downloaded the materials. This is where X, Y, and Z are. It's just another way to look at that, but in RStudio. That might help some folks who are having a little bit of trouble finding where things are. You must have downloaded the materials if you're trying to do this on your local computer from that GitHub page. So please make sure you have those. And if you're lost, just feel free to DM me and we'll figure it out.
Yeah, thanks, Jose. Yep. So essentially you can run code by clicking the green play button here within a chunk, or put your cursor anywhere on a line and press Control Enter. And the output appears down here in the console. So 2 + 2 is 4, cosine of pi is indeed -1, or you can highlight multiple lines of code and press Control Enter to get them both. So yeah, if you're coming from Stata or something, this might be like your do file, essentially. And the output appears in the console. So to reiterate what Jose said here, right? So the upper left, this is going to be our input. Looks kind of confusing, a little intimidating right now. But this is where we're going to type our instructions. As Jose said, this contains all the code that we're going to walk through today and tomorrow. We're going to run code along with some text to explain it, and the output of that code is going to appear in the console in the lower left. This greater than symbol here is called the prompt. And we can also treat the console like a scratch space as well. So if we just want to kind of test some things out, and we don't necessarily want to save them in our chronological script, we can just play with them here. You want to find out what the log of 54 is. Oh yeah, it's 3.99. But maybe you don't necessarily want to save it in your script. You can just noodle around here. And then again, yeah, in the lower right, you have all of your file system here. You can go all the way back to your home file, just like you would on your Finder here on a Mac, or your File Explorer on a Windows machine. Yeah, there's a good question in the chat here. How do you open the HTML files in your web browser? You should just be able to double click it and it'll open up in whatever your default browser is. You can think of this HTML file as like a local web page, so it doesn't even really live on the internet anywhere. You're just using the web browser to open it. Okay, and then this is an R project. You'll notice that there is a SICSS-Howard Mathematica R 2020 R project file. And again, this is something that, you know, I encourage you guys to reach out to us about, but our projects are a great way to essentially handle your working directory. So a working directory, basically your actions in R and RStudio are relative to a location on your computer. So by default, when you save and load things, those actions are relative to this particular folder called the working directory. And our projects are a really great way to stay organized for organizing your project and its context and keep everything in a single location kind of bundled up. You can retrieve a working directory via a file path, and you can also change the working directory. All right, so we won't talk about working directories too much, but just know that all of your actions are relative to a location on your computer called the working directory. And by kind of bundling up your projects as an R project, you can kind of take care of all that in one step. And again, here's a link for you. This is not, we're not here to kind of, tell you how everything works because we only have 6 hours this weekend. So there's a lot of links for you. Like I said, please keep a list of questions and reach out to us throughout the course of the summer. All right, so let's jump into some actual R. So let's talk about the basic building blocks of R programming. And you'll find that no matter how complex of a task you're faced with, you'll pretty much always return back to the same basic building blocks to accomplish it. But again, this sort of creative aspect, how you arrange these basic building blocks in creative and specific ways will allow you to create something meaningful. All right, so some basic vocabulary for you guys if you're taking notes. We're interested in objects, functions, and arguments. So everything that exists in R is an object or some piece of information or data that can be manipulated. Almost everything that happens is a function call. A function is a command that performs an action on a thing, and the functions virtually always contain trailing round parentheses. The things are called arguments, and these arguments, are defined in function creation as what are called parameters. So let's use a natural language analogy. If I say, Evan threw the ball, what do you think the function in that sentence would be? If the function is our verb. Evan threw the ball, exactly. And what did Evan throw? Yeah, the ball, exactly. So in this case, through would be the function and ball would be the argument. So we could write it like this in R. Right? Through is performing the action on the thing. The thing that the action is performed on is the ball. Of course, this won't work in R because there's no function called through. Right? But this is what we're going to do. We're going to write functions with trailing round parentheses, then we're going to put the arguments inside of those round parentheses. Well, how do we save data in R's memory? We do this with what is called variable assignment. Variables, which are also objects. Objects are just things that have properties that define how they work. And we use variable assignment to save data in R's memory. This saved data lives in a physical location on your computer. And just like, a high school math class, think back to trigonometry or algebra or something, variables are just placeholders that can contain virtually anything. Values, mathematical expressions, text, functions, or entire data sets. All right, so these are kind of the 4 building blocks that we're going to be using. So we're thinking about objects, right? So a car might be an object and have certain properties, and a ball might be an object that has different properties. And we can't treat them the same because the properties differ. Because those properties differ, we can call different functions on them. Those functions take different arguments, and we can save them to variables to save them in R's memory, and they'll live here in the global environment. Okay, now note this strange looking left arrow. This is called the assignment operator. It assigns values on the right side of it to objects on the left. So after executing X assignment operator 5, we have then saved the value 5 inside of X. And this is kind of mathy, but you can think of it like X is defined as 5, X is assigned to X, or more simply, X is equal to 5. Yeah, Susanna asked, can you use an equal sign as an assignment operator? So could you say X equals 5 as opposed to X assignment 5? And the answer is yes, but it won't work in all cases. The assignment operator, this thing here, is the highest level of assignment, and we recommend you use the assignment operator as opposed to the single equal sign. All right, so once we do that, if you scroll down to line 116 here, and you can put your cursor on line 116 and press Control Enter, look what happens to our global environment here. X appears. We don't see any output because we haven't told R to show any output. Right, so we can say X is equal to 5, X is defined as 5, or 5 is assigned to X. And this is the assignment step. We've simply assigned 5 to the variable X. If you want to print the contents of X to the screen, you have to call the variable. You can place your cursor on line 117 and press Control Enter, and 5 will print to the screen. You see a 1 in square brackets here. R is a 1 indexed language. That means counting starts from 1. And there's one thing in X, the value 5. We can also see that here in our global environment. Alternatively, you can highlight both lines and press Control Enter, run them both simultaneously, or simply click the green play button simultaneously as well. All right, so let's take a pause here. We know this is a lot here in the beginning. So variable assignment, you'll find yourself doing this 95% of the time in R. What does variable assignment mean? Well, you're saving data in R's memory that lives in a physical location on your computer. How does it work? Well, we use this assignment operator here, and we save the thing on the right-hand side to the variable on the left-hand side. And again, we can save virtually anything: values, expressions, text, and entire data sets, which is what we are working up to. So questions? Are you frustrated? Are you joyful? Can you do it? Type the name of your favorite beverage in the chat if this is making sense. Cool. And it looks like there's a hand raised here. Please go ahead.
Can you assign a variable a text? You know, can you so you see how you have the values here in the environment?
Yep.
So X equals 5. Are you able to do X equals negative, X equals positive, X equals strong feelings, X equals anything like that?
Absolutely, yeah, and we'll get to that in just a moment. Yep, so maybe you have a Likert scale or something based on, you know, satisfaction 1 to 5, where 1 is extremely dissatisfied, 2 is dissatisfied, 3 is neutral, 4 is satisfied, and 5 is extremely satisfied or something like that. Yep, so we'll cover that next. Good question. All right, so let's talk about types of data. And like everything else in R, data have a class or a type associated with them, which determines what we get to do to it. We can use the class function to find out. In this case, if class is the function, the variable x is the argument. So let's talk about 5 basic types here. By default, all numbers are saved as numeric type in R. These are just decimals, or you'll hear them referred to as floats or doubles, but they're just our decimals. Character data are text, and they're always wrapped in quotations. These are single or double quotes, but you can use either, just be consistent. Logical data, your only options are true and false, note the all caps. These are stored internally as 1s and 0s, and as such take on mathematical properties. These are useful for both subsetting data, as you'll see in a little bit, and also for turning arguments within functions on or off. So within a function, there's a lot of options that you can customize. Sometimes we'll use true to turn some option on, or false to turn it off. Our integers are positive and whole numbers, positive and negative whole numbers, including 0. And R refers to categorical data as factor class or factor type. So we've defined X here. So let's check its class here. In line 135, what's the function and what's the arguments? And based on what we just said, what is the class of X? Yeah, thanks, you guys. Yep. And what is the class of X? It is numeric. So this is numeric type. So that means X as an object has numeric data properties. So we can do things like math on a numeric variable that we might not be able to do on a character variable. Okay, so the second type is character type. Note that within a code chunk, we can use a hashtag to comment our code. And furthermore, we can call variables anything, but we'll use a space, we'll use an underscore to represent a space in the variable name. And you can have as many as you want. But the idea is to keep your variables short and descriptive of their contents. So here we do the same thing. My name is the variable name. We put the assignment operator, and my name is Evan. Haha, nice. And we wrap whatever text we have in quotes. And it can be a sentence. It can be multiple sentences. It could be the text from an entire book. And so on and so forth. So again, how do we run a line of code? Control Enter, click the Run button, highlight multiple lines and press Control Enter, click the Play button. And we see that in the global environment, the variable my name is now stored in the global environment. We can call the variable by typing the variable name and running the code to print it to the screen. And check the class, and it is indeed character type. So what we can do to X as numeric, we probably cannot do to my name, which is character type. I see a hand. Please go ahead.
Can you hear my voice?
I can, yes.
Yeah, when you say either use like double ticks, or like single ticks, when we wrote Evan, like it doesn't matter if you just wrote like single ones.
Yeah, that would work great too.
Okay, then.
Yeah. So whatever you do, just be consistent. There's times when double quotes might be better. For example, if you're trying to nest contractions, you essentially for every open thing you would need a closed thing, whether it's a parenthesis or bracket or quotation. And this would work with double quotes because we can nest the single quote within double quotes. But if we wanted to use single quotes to add a contraction, we would have to add a backslash before it to kind of escape that character.
Yeah, I see. Thank you.
Yeah, and again, shoot us an email if you have questions. All right, logical values. If true is 1 and false is 0, what do you think true plus 1 is? What do you think false minus 1 is? Interesting, yeah. So true is 1, false is 0, true plus 1 is 2, false minus 1 is -1. All right, so you'll see that true and false take on mathematical properties. You might see this in data sets as a yes or no class representation, or has a student submitted their homework, yes or no, true or false type of thing. But we can also do logical testing here, and this is really important for subsetting data, where we say, give us all the students in the data set who scored greater than an 80 on math. Only those rows with true for that condition will be returned. So I ask you guys, if true and false are your only options, is 3 greater than 4, true or false? What do you think? False, exactly. Is 4 less than or equal to 4, true or false? True. Is capital A apple equivalent to lowercase a apple? Hint, R is case sensitive. That's false. We can also use, so that's 2 equal signs is how you check for equivalence. And exclamation point equal sign is not equal. So does capital A apple not equal capital A apple? Is apple not equal to apple, true or false? All right, so we're going to return to this when we do data subsetting, and this is how we're going to subset by condition. So we're going to say, give us all of the states that are equal to California. Give us all of the students who scored less than 80 on reading. Return all of the students who are taller than 7 feet, and so on and so forth. Okay, integer type are our positive and negative whole numbers, including 0. And we can use what are called as-dot functions to convert data types. To convert numeric to integer class, for example, we could type something like this. We're getting a little more complex. We're still performing variable assignment. We're now defining a variable named y, but look at how we're manipulating the right-hand side of our assignment. So we know X is numeric type here, but now we're wrapping X in as.integer. As.integer is used to convert something to integer type. So what do you think the class of Y is going to be? It's still 5, but what's the class of Y? What do you think? Try it out. Yeah. So we've converted X equals 5 to Y equals 5, but we've changed the type of that data. And this is useful oftentimes for memory purposes. If you have to conserve memory, you might want to save things as integer rather than numeric type. And also for statistical modeling, your independent and dependent variables might have to be a certain type So you may have to do some conversions before the modeling will work correctly. Notice in the global environment, we see y is equal to 5L. There are artifacts of the C programming language in languages like R, and this stands for long form integer. So whenever you see an L after a number, you know that means integer. And then finally, there are other as dot functions like as character, as numeric, and as factor, to name a few. And we can convert mostly text or character and integer data to factor type if we want to give it grouping properties. So let's define a variable named school, and we'll define school as Stanford University. We see the quotes here, so we know it is character type. But we can convert it to factor if we want to give it grouping properties. This can be useful for not just visualization and summarizing data, but also doing things like t-tests and one-way ANOVAs, where we want to make sure that R understands that certain data should be grouped together. So just like above here in as.integer, we can use as.factor to convert this character variable to a factor type. So now R knows that all the Stanford universities belong in one group, all the Howard University data belong in the second group, all the UC Berkeley data belong in a third group. So maybe if we're making visualizations, R knows that each of those three schools should receive a different color for the points in our graph. Okay, so everything we assign as a variable lives in this global environment. But we can also just type ls. This is the list function. This works differently in different programming languages, but in R, ls, notice we still need the open close parentheses. It takes no arguments in this case. We can print the variables we've defined to our console here. Here we have 5. Note that the 5 here simply means that y is in the 5th position. We'll talk about indexing in a little bit. But we have 1, 2, 3, 4, and 5. If I were to squish my window a little bit and do this again, basically, we'd get the same thing. But check out how the row shortcuts are being represented. We still have 5 things, but these numbers in square brackets are just telling me what index or what position each of these exist in. So my name is still first, school is still second, school fac is still 3, X is in position 4, and Y is in position 5. And if I make my window super wide, the same thing happens, but I just have a wider output now. And it all depends on the width of your window here. Well, what if we want to delete a variable? We can use the rm function. So if we want to delete my name, we can pass in my name as the argument to the rm function. Rm is short for remove. And what happens if I try to call my name? I get an error saying object my name not found. Why? Because, well, we just deleted it. And use autocomplete as you type. So if you start typing in your console or your script, use that autocomplete. You can either use the arrow keys or the tab key or enter key to select something, or point and click with your mouse. But if you're doing this for 12 hours at a time, maybe your deadline's tomorrow, it's very easy to make spelling mistakes. And then we can delete all of our variables by clicking this yellow broom here in the upper right. Are you sure you want to remove all objects? We can say yes. Or we can pass in a list of the objects in our global environment and remove them all. And then we're back to kind of square one. If your console here is getting too messy, right? So the yellow broom deletes all the objects in your global environment. But this little broom, this gray broom, or Control L, will bring the prompt back up to the top of your console to make it a bit easier to read. So you'll see once we start loading up data, if we have a bunch of stuff in our console, we might have to do a bunch of scrolling to find out what we're looking for. But if you press Control L first, that output will be at the very top. So that makes scrolling quick and snappy. And then to completely restart your R session, to just have a totally clean slate, you can click Session from the top menu and restart R. And now we're back to truly back to square one. Okay, so questions. We talked about variable assignments. If you got a pen and a pad or a Google Doc open or something, make sure you understand variable assignment. We put the variable name on the left-hand side, the assignment operator in the middle, and then the value to be assigned on the right. We're talking about 5 different classes of data at the moment. Numeric type, that's the default for numbers in R. Those are just decimals. Right, this is one drawback of R. It's very memory hungry because it's storing everything as 64-bit floating point numbers. So if we see 5 on the screen, R is maybe actually storing it like this. So that makes it very memory intensive, much more so than a language like Python or Julia. Our character type, those are values or text or anything that's wrapped in quotations, single or double, doesn't matter, just be consistent. Logical type, true and false. We'll get into what true and false mean in action here in a little bit. Integers, whole numbers, and factor type. That's just how it refers to categorical data. Okay, how you guys feeling? Press Control L to clear your console. Click the yellow broom here to delete all of your saved variables and click Session, Restart R to restart R. How you guys doing? Put the name of your favorite food in the chat if you're feeling okay.
I'm feeling okay, but I have a question.
Please.
Can you scroll up a little to any chunk? I tried to type the chunk just as you have it in a new script, and it gave me an error. You know why that would be?
Yeah, so if it's a script, and our script will not utilize our chunks. It has to be in a new markdown file.
Ah, okay. So those 3 things will work only on a markdown.
Correct. Yep.
Okay. Okay. Thank you. So you cannot do chunks in a script then?
Correct.
Ah, okay. Thank you.
Yep, because in the script, R is trying to interpret this as actual code. Let me get this error message here. All right, so let's take some time here. What questions do you all have? We got donuts, pot stickers, and bolognese, which are all fantastic, but for 16 participants, that's not a lot of food. Question, I see a hand.
Yeah, I had a question about where the text, I think it's called. So I put in the my_name the example where you had put Evan, but it didn't, it gave me an error message. It didn't come up as a variable. So I was
Sure.
just wondering what I did wrong.
Yeah, what does the error message say?
Oh, let me go back up. Oops. Let me do it again.
Yeah, no problem.
It's not, I guess it's just not doing it. So I have my underscore name and then I forgot what that's called. I know it's pretty sensitive, so I don't know if and then I have the Evan in quotes.
Mm-hmm. And do you have 3 backticks appear and are in curly braces?
Oh, it's not in the code. It needs to be in there.
Yeah.
Okay.
So then that way, when you convert the markdown to something else, R knows what code should be represented as instead of just text.
Okay, thank you.
Yeah, you're welcome. Yeah, great question. Okay, so we'll take a break in a little bit here, but let's cover data structures and give you a little chance to apply what you're learning here. Okay, so if saving one piece of data in a variable is good, saving many is better. So we can use the C function, this is short for combine or concatenate, multiple pieces of data into a vector. A vector is an ordered group of the same type of data. Doesn't matter what type of data it is, as long as it's all the same. We can nest the C function inside of as.dot functions to create vectors of different types. Okay, so now we're going to put functions inside of other functions. Here's an example with a numeric vector. All right, so numeric is the default type for numbers. So here we have a variable called traffic underscore stops, our assignment operator. And then we have how many arguments inside of the C function do you think? And what are they separated by? Yeah, we have 6 arguments, 1, 2, 3, 4, 5, 6, and separated by a comma, indeed. Now, what's going on here in line 228? We're doing something similar, but what type of vector is this going to be? How many arguments are there? And what are they separated by? What's the variable called? And so we're still using these same building blocks here. Yeah, good, you guys. So we have 6 arguments inside of C, but inside a factor, maybe we have 7 arguments actually, right? One of them being a function. They're character type, they're separated by a comma, but how are we designating them for this variable? Yeah, as a factor. So we're saying give these SF and DC entries as categorical type. So all the SF data should be together, all of the DC data should be together. Same thing in 229. Now we're making an integer vector called year that also has 6 entries that are being parsed as integer type. Okay, so now I call traffic stops, but I get an error message, classic R error message, object traffic stops not found. What have I forgotten to do if I get this error message when I try to call this variable that I supposedly assigned up here? Do I see it in my global environment? right? Same thing with city. Object city not found. Try to run year. Object year not found. Why am I getting these error messages, do you guys think? Says my environment is emptied over here. Yeah, Jose, please.
Oh, I was just responding to the question of like when we convert them to factor, is it automatically assigning them to numbers?
Yep, exactly.
Yeah.
Yep. Oh, yeah, I saw a hand. I thought that was a question there.
Oh, sorry. I didn't even mean to do that. I don't know why I did that.
No, that's Zoom for you. Yeah, good. So good question. Yep. And exactly. So I forgot the assignment step here. So R is saying, I don't know what year is because we have not yet assigned it. So if we assign these variables, we see them appear in our global environment. And then we can do things like check their class. We can print them to the screen. Traffic stops has these 6 entries. City has these 6. We see we get a levels piece of information here. Levels are the groups within a factor variable or a categorical variable. And here we have these 6 entries. We can check the class of each, but check it out. Our global environment is giving us this information as well. So we know city's a factor. We know traffic stops is numeric, city's a factor, and year is an integer.
Do you mind explaining why it says factor with 2 levels? At what point did you create the 2 levels?
Yeah, that's a great question. So the 2 levels were created automatically when we assigned this as a factor vector. So here, if we don't do as dot factor, R is just going to think this is character data, right? R is just saying this is text. I'm not going to assign it any grouping properties. But by wrapping it in as dot factor, watch this change from character to factor. And since we have 2 unique groups, SF and DC, R is saying there are 2 groups here. There's some discussion in the chat that we're going to store alphabetically as the 2 levels or the 2 groups within the factor variable. Does that make sense?
It does. Thank you.
Yeah, you're welcome. Yep, and there's a question about are the factor levels always in alphabetical order? Can you change the order levels? Absolutely. R sorts things alphabetically by default, but you can, as Jose said, you can change the order. You can make them ordered, and you can also relabel and relevel them. All right, so why are we doing this? Well, we're working up to a data frame, which is an ordered group of equal length vectors. And what's the length of city, traffic stops, and year? Well, those are all length 6. So we can line them up as columns next to each other into a rectangular tabular data set, basically a spreadsheet. And a data frame is really just a tabular data structure organized into horizontal rows and vertical columns. This is just a spreadsheet like you would see in Excel. These are often stored as comma-separated values files or plain text where commas are used to delineate column breaks and that look good in these different spreadsheet programs. All right, so before we load some real data, we're kind of just working up to this idea of a data frame, aka a spreadsheet. So we can assemble these 3 vectors into a data frame with the data frame function. So let's call this variable police. On the left-hand side, in the middle, we still use our assignment operator. And then on the right-hand side, we're using the data frame function. What are the 3 arguments inside of data frame? Rhymes with Hector. Yeah, these are our vectors. So we run line 248 and we now have, instead of values, we have an object under data called police that actually looks like a data set. If we look at the class of police, it is a data frame. Yep, thank you, Jose. Just put a great link in the chat about working with factors. Yeah, Grace asks, are data frames always combined by columns? Not always, but in this case, yes. The vector is always going to be a column. And this really represents the strength of the tabular data structure, because look at each column. We only have the same type of data within each column. But we can line up vectors or columns of data of different types next to each other. And what this produces is heterogeneous data across the rows. So we still have the same type of data within a column, but we can have different types of data across rows. And this is one thing that really makes summarizing, visualizing, and analyzing data very, very quote unquote easy. Easy doesn't mean simple per se, but easy in a language like R. Yeah, so Andreas, so the columns are just our vectors. So city contains just SF or DC. Traffic stops contains the number of traffic stops, and then year contains that integer column of.
So I guess I was just asking, does it assign it based upon the position of the 1 through 6 that we put before? Is that how it does it?
Exactly, yep.
Okay.
So entry 1 is here, entry 2 is here, 3, 4, and 5, and 6, and so on. And R is trying to be helpful and give us these row numbers here as well. But that also begs another question about how they're entered in the data frame function. So we could say year, city, traffic stops. And we could change the order of those columns as well. Okay, so when you load a data set into R, and we're going to load a real one here in a little bit, one of the best functions you can use to investigate the data is called str. str is short for structure. If you're coming from a language like Python, it means something different. But we're saying, give us the structure of the police data set. And here we get the class. It's a data frame. We have 6 OBS. What do you think OBS stands for? And 3 variables. Yeah, so we have 6 observations. Are those rows or columns? Yeah, thanks, Christina. So we have 6 rows and 3 variables. So now we have sort of this duplicative identity of the word variable. We know variable looks like this when we perform variable assignments. But within a data frame, a variable means a column. So these are also our variables within the police data set here. All right, so now variable has 2 definitions for us. One when we're performing assignment, police is a variable. And one when we are talking about the structure of the data. Observations are the rows, variables are the column. Okay, and now check it out. Our columns are preceded by a $sign here. We have an example of the type or the class of the column, and then examples of the data. And the reason the columns are laid out as rows here is because if you have 50 or 500, it's going to be easier to scroll up and down like this than it would be to try and scroll left to right. But we know they're columns because they're preceded by the $sign. And we'll talk about why here momentarily. Okay, that was a lot, you guys. Thank you for your patience. Let's go ahead and take a break and we'll come back and do this challenge question here. It is 1:10. Let's reconvene at 1:25 and we'll work on this challenge question here. So try and go take a stretch, take a bio break, go get some fresh air, refill your coffee cup, and we'll come back and do this challenge. We'll give you a few minutes to work on it, then we'll go through it as a group. And then we'll talk about indexing and subsetting data as we start to load up some real data sets. So thanks for your patience, everybody. Thank you, Jose, for your help, and see you in 15 minutes. Please think of some questions too. And I'm happy to take any questions during the break, you guys too.
Yeah, I can ask you here. So before I tried doing the like going back to that because I don't know if I'm doing something wrong, the my underscore name. And I put the assignment, forgot what it's called. I put that in there, but it's still not showing as a variable.
Yeah, are you able to share your screen? Do you have that option?
I don't think I have. Oh, yeah, I do.
Okay, would you mind sharing your screen real quick and we can sleuth it?
Okay. So it's like this here. So I did this one, but that one I didn't.
Yep, so what you want to do, you see how lines 15 and 16 are wrapped in a code chunk. So what you want to do, go to line 20. If you click on line 20 and basically copy line 14 to line 20
Copy line 14.
to 20. And then copy line 17 to 25. Yep,
20.
so maybe before as dot integer.
Okay. Like there.
Sure. Yep, so now R is treating that as a code section. So now if you close the quote on line 21, see how you got the open double quote there, put the double. And now if you press Control Enter. Yep, and then add a new line 22. So press return.
On 22.
Yeah, before the back ticks there.
So just
Press enter. And then on 22, type my name. And then you can run that code and it will print to the
my underscore name.
Yep.
And pretty much I'm doing the same thing.
Exactly. But now don't do assignment. So now if you just run line 22, just do Control Enter, it'll print it to the console. So now you're good to go. Just delete that X in your console.
In here.
Yeah. Right. So now you could change in line 21, you could change my name is equal to Renee. And then assign that and you'll see it change in your global environment.
I could pretty much Control Enter.
Exactly. You don't no highlighting necessary. And then you can see it changed in your global environment. So now if you press Control Enter again to call that variable, calling just means showing it on the screen. And this time it returns Renee. So the problem was the code just wasn't in a code chunk. So RStudio didn't know it should be treated as code.
Okay, even though it was in between these like these spaces here.
Yeah, now it is. So now it works.
Okay, so then how do I make it as a variable?
It is a variable. Yep. You see how it's under the values section of your global environment.
Oh, so how come it's not showing up on this side?
Because the environment is kind of just for storage. It's just a list of the data you've saved in R.
Okay. All right, thank you.
Yeah, I know it's confusing. Keep asking questions.
All right, thanks.
All right, we got another 5 minutes here, you guys. Okay, welcome back, everybody. I know it's been a talk-heavy day one here. We will be doing more challenge questions, especially tomorrow. But we'll try to kind of get you familiar with data, build your data literacy here in the next few minutes, and then kind of put it all together into a computational workflow before we do our deep dives tomorrow, which I think there's 7 or 8 challenge questions tomorrow. So let us apply what we've learned, and I ask you to create a data frame that contains 6 rows and 3 columns. Anything you want, could be names of animals or students or places or foods or fruits or whatever, by following the instructions above. If you are already an R user, let's talk about what the difference between a data frame and a tidyverse Tibble is. So we'll be using Tibbles a lot tomorrow when we talk about the tidyverse. So if you're already an R user, if you're intermediate or advanced, kind of make a list of what the differences are between a Tibble and a data frame. Go for it. Jose and I are here. Ask us questions. Take about 5 minutes. Go. All right, so I put a little mini review in the chat here, but we basically covered like 6 kind of main concepts, right? talked about objects. Everything in R has a class which determines its properties, how it behaves, and what we can do with it. Functions perform actions on a thing. The things are called arguments. Number 3, variable assignment. We use the assignment operator, this less than hyphen symbol, leftwards pointing arrow, to save whatever's on the right side to the variable name on the left side. We talked about number 4, 5 data classes or types so far: numeric, character, logical, integer, and factor. Number 5, a vector is an ordered group of the same type of data, ordered just meaning that position matters. And number 6, data frame is an ordered group of equal length vectors organized into rows and columns, aka a spreadsheet. And we'll say where the vectors are the columns. So take a screenshot or copy paste those to your notes doc. And these are the things we'll kind of keep coming back to. And who's got some code? Did any of you make a data frame? We'll talk about subsetting data frames here shortly. Then we'll load up some real data and put this all in context. Anybody want to share? Cool. Thanks, Erica. Okay. We'll try Erica's example here. And here we have 3 vectors, each length 6. Fruits has 6 entries. This is character data: apple, pear, grape, cherry, raspberry, blueberry. Veggies also has 6 entries: zucchini, kale, carrot, lettuce, parsley, and beets. And then quantity has 6 entries: 5, 3, 2, 1, 5, 6. We perform assignment by using the C function, right? These are all the same types of data within each of the vectors. So fruit is all character, veggies is all character type, and quantity is all numeric type. And then we can assemble these inside of a data frame named df, in which we're saving these 3 vectors, fruits, veggies, and quantity, inside of a data frame function to produce something like this. And then, of course, what's the 3-letter function you want to use anytime you get a data set into R? Check it out with str. And you can get the types of those columns and examples of the data as well. All right, we got a couple more here. Very nice, thank you. We got food, quantity, and supermarket. And we do the same thing here. We define 3 vectors. Food is a factor, quantity is an integer, supermarket's a factor, and then we can put these in to the data frame function as our columns. And we get something similar here. And same thing with our zoo animals. We have a vector of animal type, animal color, and animal height. And then these are combined within the data frame function to produce our little table of animals. Okay, so in real research, we might not be creating data like this, but the idea is to get you to understand how the parts work. So now we're going to subset our data frame here, our little toy one, and then we'll load up some real data and apply what we've learned. All right, sound good? We got 1 hour left. You guys ready? Thank you for your engagement so far. This is really great. This is a lot of fun. All right.
So I have a question.
Please.
So you put it like the second question: what is the difference between data frame and type versus type? I don't know how to say that word.
Tibble.
Tibble.
Yeah.
And then I haven't used this Tibble before, but when I did, it seems really the same, but it seems that there's different vectors connected. But could you explain the difference?
Yeah, sure. So we'll focus on Tibbles tomorrow. And essentially, there's two main differences between Tibbles and data frames. And the first is that when you print them to the screen, a Tibble will never print more information than the width of your window can provide. So in terms of kind of summarizing what's there, it tries to be more efficient in printing to the screen. And then also for subsetting, we can store lists. So we can store vectors or lists inside of single cells of a column of a Tibble, which we can't do in a data frame. So if you look at part 2, where are we at here? For tomorrow, we can actually store, let's see here. Yeah, so we can actually store lists inside of single columns of a Tibble, which we can't do in a data frame. So we can essentially, if we wanted to, I don't know, run a dozen linear regressions on a single data frame, we could store the data in a way that would allow us to do that, which wouldn't be quite as easy in a data frame. So more on that tomorrow. All right, great question. Okay, so let's talk about indexing. So a vector can be indexed. Index just means positionally referenced by typing its name, the name of the vector, followed by its index in square brackets. So we've been using round parentheses up until this point in time with our functions, right? Now we're going to use square brackets, these ones here. Okay, so if we want to index just the first thing in the city vector, we could type this here. Okay, so let's look at the city vector. We have San Francisco, DC, 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 San Francisco, San Francisco. So if we wanted to just extract the first item in the city vector, we could type the name of the vector, followed by a 1 in square brackets to get, the first entry, which is San Francisco. What do you think I'd type if I wanted the second entry in city? Right? And it should return DC, right? And there's DC. Or the third, or the fourth. Oops. What if I try to get the seventh thing? What is returned? NA is the only way that our code's missing data. And this is basically saying there's nothing in the 7th position. In some instances, this will throw an error message, a range error saying there is no 7th position. But in this case, we just get a NA. All right, alternatively, well, check this out. So we can also call it from the data frame. So police is our little traffic stops data frame. But remember that $sign? Type the name police. It can even be here in the console. And then the $sign. What appears? The names of our columns, right? So this is a great way to extract just one column from a data frame is with the $sign operator. And this is useful if we want to view just a single column at a time. We'll talk about this in more depth tomorrow, but we could also call the column from the data frame using the $sign and then index that with our square brackets. And this is useful because we can plug it into other functions like hist. What do you think hist does? Yeah, make a histogram. And we'll talk about this more in depth today and tomorrow. Okay, if we just want the third thing in traffic stops, right, we could put a 3 in square brackets. The third thing is 9,829. Or we could do the same thing from the data frame. So we can positionally reference parts of a vector or a data frame using these square brackets. So remember, yeah, use that $sign. If we look at str of police, we see that our columns are preceded by a $sign. And we can access a single column from a data frame by typing the name of the data frame, police in our case, followed by the $sign, and then we get our autocomplete list of the columns. So if we just want to look at the traffic stops column, we can just extract that. If we want to do a t-test or we want to make a scatter plot, we can just say plot this column on the x-axis and this other column on the y-axis. And again, we can easily plug it into other functions. All right, so make a note of the $sign. But it gets better. We can subset, so the $sign only works with a single column. But what if we want multiple columns or multiple rows or rows and columns? We can use bracket notation here. So remember, when we're subsetting a vector, we just put a single number inside of the square brackets to positionally reference or index something from a vector. Well, we can do the same thing in 2 dimensions using bracket notation. So now we're going to type the name of our data frame followed by square brackets with a comma in between them. And here we can enter 2 indices. The one before the comma is for the rows. The one after the comma is for the columns. All right, so if we want 2 columns, we can't use the $sign operator because it only works on a single column. But we could type the variable or column names or their positional references in that column position. If either the row or the column position is left blank, all rows or columns will be returned because no subset was specified. Okay, so what if we want to subset the police data frame with just the city name and number of stops? So let's look at our police data frame here. We just want city and number of stops. So these are our first 2 columns, right? So check it out. We're still performing variable assignment. We're going to create a new data frame called city and stops. And we are assigning to that a subset of the police data frame. We're leaving the row position here blank because we're saying we want all the rows returned. But now we're passing in a vector of the indices of the columns we want, which is just 1 and 2. And now essentially we have excluded the year column. We've only included the first 2. But for consecutive sequences, we don't need the C function. We can just use a colon. Check it out. If we want numbers 1 through 10, we can just type 1:10. And we get a consecutive sequence of whole numbers where by equals 1. Or if we want 5 through 8, we can say 5:8. So in this case, we're saying give us 1 through 2. And we get the same output. Or we could do this by calling the column names. So this is 3 different ways to do the same thing. Type the name of our data frame. We open up our bracket notation with a comma in the middle. The row position, everything before the comma is blank. We're telling R we want all the rows returned. And then we can just type in a vector of the columns that we want. Right, so this is how bracket notation works. But we can also add something in the row position. So in line 338 here, what is 1:3 going to return? In the row position. What do you guys think that means? If these are the columns, yeah, thanks you guys. So now we'll get the same, we'll get these two columns, but just rows 1 through 3. So the colon works with consecutive sequences of numbers. But if we have interrupted sequences of numbers, like if we want rows 1, 2, and 4, we would have to use the C to vectorize those rows. So here in subset 2, check it out. We're still performing variable assignment. We type the name of our data frame that we want to subset. We set up our bracket notation, square brackets with a comma in the middle. We positionally reference rows 1, 2, and 4. And then we can call the columns we want by typing the variable name or their index. And here's our trying to be helpful. They're saying, here's row 1, here's row 2, but here's row 4. So we could reset those if we want. But that's our trying to be helpful. All right, so it gets better. We can subset by logical condition. Remember those logical operators from earlier. Double equal sign is equal to, greater than symbol, or less than equal to, so on and so forth. Scroll back up to the logical data section. But what if we wanted to subset only rows with stops less than 9,000? Here, we can combine the $ operator with bracket notation, right? So we're kind of teaching you the long way of doing this today. And tomorrow, you're going to learn the tidyverse way, which is a really efficient shortcut for wrangling data like this. So we only want stops less than 9,000. So if we look at the police data set, we should have 3 rows returned: row 1, row 5, and row 6. Okay, so keep in mind, this is a row subsetting operation. So we're going to put everything before the comma. And this is a row subsetting operation based on the condition of a column. So we're telling R, we want all the rows where the condition of a column is true. What's the condition? Well, stops less than 9,000. All right, so let's put bracket notation and the $ together. We're still performing variable assignment. We'll call this low stops. Here's our assignment operator. We type the name of our data set to be subsetted. We set up our brackets. And now we are going to add that column condition. So now I type in the row position, police $stops is less than 9,000. I still include the comma because we're telling R we still have 2 dimensions here. And we leave everything after the comma blank to get all columns returned. And lo and behold, rows 1, 5, and 6 satisfy this condition of stops being less than 9,000. So they're returned in the subset. Alternatively, we can combine this with logical and logical or to subset based on multiple conditions. So logical and is represented by the ampersand, that's Shift 7 on an English keyboard. And that means all conditions must be satisfied to be included in the subset. Logical or is the vertical bar or pipe. That's a Shift / on an English keyboard. And that means just one out of many conditions needs to be satisfied to be included in the subset. So what if we want rows that only contain San Francisco is the city and stops less than 7,000? So now we can do what we did above, but for two conditions. Right, so same thing. We're still performing variable assignment. So we're going to call this subsetted data frame SF low stops. And put our assignment operator. We type the name of the data frame we want to subset. And then we can add our conditions. Again, these go in the row portion of the brackets before the comma, because we want all rows returned that are based on the condition of one or more columns. So we want rows that only contain San Francisco as the city and stops less than 7,000. So this is a little duplicative. Like I said, you'll see the shortcut tomorrow. But we can say police $city is equivalent to SF and police $traffic stops are less than 7,000. And just row 5 satisfies that condition. All right, so let's pause for questions. Let's pause to apply what you have learned here. Okay, so create a subset that contains data from DC or stops less than or equal to 7,000, along with just columns, city, and traffic stops. For you advanced users out there, try and do this using filter and select from dplyr. For everybody else, we're going to do number 2 a bunch tomorrow. All right, so give it a shot. We'll talk about getting help, and then we'll put this all together. We got about 40 minutes left. You guys are doing great. You know, and one thing I like to do, let me see. Right, so it's kind of like I'm a big visual learner. Like I always have a journal and like colored pencils on me. Like I'm always scribbling on napkins and stuff. I'm a very slow learner. So one thing I like to do is kind of make a table like this and just sketch it out and say, what's the concept here? All right, so the concept is we need to subset police data frame. And in our code, this could be done with, let's make this a little. Right, so I need variable assignment, bracket notation, and the $sign. All right, the second task is to subset where city is equal to DC. All right, so now I know I'm going to use my equivalent logical operator. Logical and, okay, and I need the ampersand. Sorry, this is or. So we didn't do an example of or, so I'm kind of counting on you to use your intuition here. All right, so I need the pipe less than or equal to, along with less than equal to. Return column, city, and traffic stops. So I know I'm gonna need city and traffic stops. Right, so it's kind of like this, you know, if you take a, you know, a test in one of your classes or something, and you have a math problem that's presented to you as like a text question, right? You kind of have to decipher what the text is asking first, and then break it down into subsets here. So maybe, you know, take a screenshot of this if it's helpful. This will be on the recording as well. But for everything I do, I'm doodling in the margins. I'm like, you know, like making a flow chart. And it, you know, with some practice, it really helps me grasp, like, what am I really trying to do? And how do I break down one task into the subtasks so I can understand what's helping? You know, if you have a whiteboard or a chalkboard, do the same thing. If you take voice notes, you know, do the same thing with voice notes. If you have a recorder on your phone or something. I talk to my dog all the time. You know, whatever helps you kind of, yeah, exactly, Jose, just to reinforce what's being asked. All right, so take a few minutes and ask us questions. After this, we'll talk about getting help, and then we'll load up some data and put it into context. And I'll be right back. And we got a good example in the chat here. Let's give it a try here. Check this out. Error in if drop the condition has length greater than 1. Can anybody spot the error here? What's going on in line 1 here? And this is what real programming is like. It's 4 in the morning, your deadline is at 8 a.m. You got to give a talk. And what's going on here? Look at my highlighted code. Yeah, Imani, yep. So here, a typo, right? I was falling asleep at my keyboard and you will waste hours sleuthing stuff like this. Like for real, like as if like understanding all this is not complicated enough, you know. You know, it's like in your, you know, you burn through all your productive time searching for a comma. Like, you know, so like take breaks, go take a walk, walk your dog, do, you know, wash dishes, do something. Because not only do you have to understand all this complicated stuff, it's like my, you know, I bumped a key type of thing. So here we're using logical OR, and we're saying city is DC or stops are less than 7,000. So why is San Francisco included if city is supposedly equal to DC? Because we're saying or stops are less than 7,000, right? So since the stops condition is satisfied, row 5 is included even though the city is DC. And then I think there was a couple other, we'll try Erica's here. And then I think there was one more. So we got rows 2, 3, 4, and 5. And here's the dplyr solution, you guys. Thank you so much, Erica. We'll focus on this tomorrow. And you'll see it's the same results, but the row indices have been reset. So this is how you can do it, kind of using some cleaner, easier to interpret code. We'll talk about what this symbol is tomorrow. What is called a pipe. Select is how you select columns, and filter is how you select rows. We'll talk about this tomorrow. And then Susanna gave us an example as well here, which works just the same. So great, you guys, go at your own pace. And like I said, you can email me. I'm here to support you guys. I hope this is not our only interaction this weekend. I have time built into my Stanford time, so don't feel bad about reaching out. It's certainly a marathon. Okay, great. So now if we talk about getting help. So R provides excellent help for the most part. It's accessible within our studio. And in my opinion, it's second to none in terms of programming languages. The help in Python is pretty good, but I still feel like in general, R's help is better. And the rub is that it tells you everything you need to know. You just don't know it yet. So the key is to type a question mark before the function name to view its help pages. Okay, so maybe if you want help with a t-test, you could type question mark t.test. Or for linear regression, question mark LM. And then you can use these blue arrows here, or we could do the arithmetic mean of question mark mean. And then you can use these blue arrows here to cycle through your help files. All right, and the key is to read the description. So we'll do t.test. So t.test is from the stats package. This is a package built into the base installation of R. We'll talk about what packages are in a moment. But read the description. Performs 1 and 2 sample t-tests on vectors of data. All right, hopefully you know what a vector is, an ordered group of the same type of data. And then look at usage. And we're interested in this default S3 method here. S3 is a type of object-oriented representation. Okay, so there's this idea of object-oriented programming, but it's basically how objects and their properties are related to functions that use them and what is output. You don't have to know about that right now, but just look at the default S3 method. T.test is the function, and then check it out. We have our round parentheses here. Inside of these round parentheses, we have the options that we can use, that we can customize. And this is one of the reasons that R is preferred to a lot of other programs, because of the amount of customization that you can include in a given function. So here we have X and Y, alternative, two-sided less or greater. Mu, this is a population mean. Is it a paired t-test? Did you measure lung capacity of smokers before and after smoking? Something like that, right? Are you measuring the same groups? Are the variances equal? What's the confidence level, and so on and so forth? Okay, so you read the description, you read the usage, and then scroll down to the arguments and check it out. Arguments tell you exactly what these are. So X and Y. X is a non-empty numeric vector of data values. Keyword numeric, this means numeric or integer. Y, an optional numeric vector of data values. Alternative, a character string specifying the alternative hypothesis. Is this a two-tailed or a one-tailed test? Mu, do you have the population mean or difference in true value? Is it a paired test? Are the Variance is equal or not? What's the confidence level, and so on and so forth. And then if you keep scrolling down, you'll sometimes get a details section that gives you more description of the function itself. Under the values section, you'll see what the test outputs. So you'll get the t-statistic, the degrees of freedom, the p-value, the confidence intervals, and so on and so forth. And then you keep going. Sometimes you'll get citations that you can reference if you're writing a paper. And then you get copy-paste examples.
I think we have a question.
Yeah, sure.
Yeah, I'm transitioning from Stata to R. So in Stata, it's a little bit easier. Let's say there is certain default, like t-test, for instance. Do you have any like source for me to kind of, if there is a code that I can see that is like, okay, this is what you do in Stata and this is how you will do it in R?
Yeah. For you Stata users out there, I thought I had a book. So maybe something like this for the t-test specifically. And please send me an email, and maybe we can post this to the Slack channel. But there's a couple of books out there that talk about R for Stata users. So if you could send me an email, and I'll make sure to get that to Nanette and post that on the Slack channel. Nice, thanks, Jose. Yeah. Yep. So there's a lot of.
Yeah. So what I would do is one way you can sort of check is like, if you're like, oh, there's a Stata command that I know, like a t-test or something. In R, you can do like help, or like you, wait, is it question mark and then the function? I think it's question mark and then the function, and it'll tell you, this is how this works. This is the example, and this is what it's doing, just like Evan has right here. That's probably your best bet. That's really how I translated a lot of stuff from Stata into R, because I was trained in Stata first. But there's a few things out there that can help you sort of just think through this, like this page. Yeah.
Cool. Great. Yeah. Okay, so that's how help works. So, just it takes practice, it takes patience. It feels frustrating, but it's once you get the hang of it, you can really become a self-learner, because well, what is the test doing and how do I use it? And then what are some references that I could check out? For example, for LM, as you can see, for linear regression, the help file is huge. But here there are the references that this particular model is based on. So you can check these out, which R is recommending. And then again, use your copy paste examples here. And for symbols, wrap them in quotations to view the help pages. So if you want to see how greater than or equivalency works, you could wrap any one of these in quotes. And same thing for your logical operators. Okay, so we got about 20 minutes left. Let's make sure we kind of put this in context, okay? So now we have some syntax familiarity and functionality, but let's work through an actual kind of example. Maybe this will spill into some optional homework time here, but what happens when you exceed the limits of what is provided by base R installations? Because R has evolved for statistical functionality, it has considerable variety in what it comes with. This means you can accomplish a lot of tasks without having to install additional packages or user-defined software libraries. But there are many instances where you will want to do this because it'll make R work a lot more smarter and efficiently for you. Okay, so there's 2 steps to doing this. The first step involves using the install.packages function or the packages tab on your RStudio and clicking the install button to physically download the files from R's CRAN server. And this physically installs the files on your computer. But RStudio doesn't know they are there. So then we would use a function like library to link those files to our current session. All right, so everybody try to run line 431 here, install.packages psych. This will install the psych package. You don't have to be a psychology student to use it. It comes with a great variety of useful research tools. One that I use is the geometric mean. So there's different types of means, the arithmetic mean, the geometric mean, the harmonic mean. And it happens to have one that's really easy to use. Okay, so we install that package, but RStudio doesn't know it's there. So now we can run the library function to link it to our RStudio session. And then with a lot of these packages, you can use the double question mark to bring up help files for packages. So here we have one called Introduction to the Psych package. And you can load up the code or the PDF. And it gives you a walkthrough of what this package does with copy-paste R code. Now, not all packages will have this, but most of the larger ones do. So now when we look at describe help files, we see that this comes from the psych package, or described by, this comes from the psych package. All right, so again, for your notes, know that external package installation takes 2 steps. Install.packages and then the name of the package in quotations. And it's in quotations because install.packages is doing a text search for a package named this. And then using library on the psych object, quotes are optional here. You can also include the quotes if you want, to link those downloaded files to your current RStudio session. And then using that double question mark on the package name to bring up help files or vignettes or coding walkthroughs for that particular package. Okay, so now if we want summary statistics, we could use this describe function and get a bunch of useful statistics. We could also do this with some built-in functions. But here we get the mean, we get the standard deviation, the median, the mean adjusted value, the minimum and max, the range. And these last 3 I'm particularly interested in: skew, kurtosis, and standard error of the mean. Skew is how the distribution is distributed left or right. Is it normal or bell-shaped, or is it positively or negatively skewed? And then kurtosis is the sharpness or the bluntness of the peak or peaks. And if you have multiple packages to install, you can vectorize them. Okay, so these are the packages we're gonna install. I don't think we're gonna get to tidy census, but if you're interested in accessing the American Community Survey or something, you can do so directly from RStudio. It's pretty nice. So try this, try to run this line here and install all these packages. If you're prompted to say, do you want to update, or if you want to restart RStudio prior to install, you can just click no. And you'll see a bunch of progress bars. And then library them one by one. And these are the packages we'll use tomorrow. All right, so we can do question mark dplyr, or question mark ggplot2. and get a bunch of coding walkthroughs for these packages. Alternatively, right, you can always do the Google search or DuckDuckGo or whatever you use, right? And we say RStudio, how to subset data. And there are tons and tons of resources. Thank you, Christina. Yeah, Christina makes an excellent point. Once a package is installed, you don't have to reinstall it every session. But if you close and restart RStudio, you do have to relibrary. Yeah. And we kind of say maybe reinstall your packages once a year, maybe. I don't know, it's hard to know how up-to-date things are unless you're staying on top of the releases, which is kind of impossible for normal people like us to do. So yeah, that's a great point. All right, so let's import some data, you guys. Let's see how this really looks. Let's do it the easy way. So in your environment tab, do you see anything that might be useful for importing a data set? Anything in your environment tab that could be useful for importing a data set? How about the import data set button? We're almost there, you guys. Another 10 minutes. So if you're coming from SPSS or SAS or Stata or Excel, you have options to directly load those files here. We have one of these CSV files, which you'll see what looks like here in a minute. So we just want the first option, from text base. And we're prompted with a dialog box like this. We want to go into the data folder, into the raw data folder, and select AZ Mesa 2020-0401 and click open. And you should see another dialog box like this. The input file, this is what the raw data looks like. This is that CSV, comma separated values file. It's just text, but each place you see a comma, that's telling R or Excel or anything that can open this where the column break should be. So we see in our data frame here, the nice spreadsheet tabular structure. We can give it a name. We can change various options here. And then if you scroll down, you can click import to import the data. And automatically by doing this, RStudio is going to run the view with a capital V function, and it's going to open this up in a sort of spreadsheet tab. And just like in Excel or another spreadsheet program, you can click the filters here to sort by date and time or location. We have some geographic coordinates here. We sort by age. So the youngest traffic stop was of a 10-year-old on April 22nd, 2015 at about lunchtime for some sort of speeding. And thankfully, that child was not arrested. And then if we look in our global environment, we can see it lives here. What's that 3-letter function we should run when we first import data? Rhymes with rupture. Do you guys remember? Yeah, thanks, Christina. Structure. So we could say str of the name of the file, use your tab key to autocomplete. And we have 96,000 rows and 19 columns, and here are the column names. All right, so if you're just getting started, this is the easiest way to import data. Click the Import Dataset button, click From Text Base, and then select your CSV file. Oops, that's the preprocessed from the raw data folder. Alternatively, you can use the read.csv function to do the same thing. So if we want to hard code this, we could do so using read.csv. How do we find the help for read.csv? Well, we can use our question mark. So even to load data sets, you guys, we're still performing variable assignment. This is data from Mesa, Arizona. So we're going to call this Mesa. We're going to use the read.csv function, open up our round parentheses, right? And then if we look at the help file, the file is the name of the file. So this has to be passed in as a character type. So we know it needs quotations. But now if you place your cursor in between the quotations and press tab, it'll automatically look in the working directory. And you can simply select the data file, assign it, and run str. The head function will look at the first 6 rows by default. Right, this is spread out, but we get the first 6 rows. We can count the number of missing values, the proportion of missing data, and so on and so forth. All right, so now we have the data in R, and basically, right, we're finally here, right? So you can see how much goes into the process. Now we can wrangle our data. We can use our bracket notation to create a data set called clean that just contains the following columns, right, to make it a little easier to work with. We can do the same thing with the column indices, get the same result. We can use various summary functions to get some quick facts about our data. So if we want to look at the subject race column, we could use the table function. And we just want cross tabulation and table creation. So look at the frequencies of the different groups, or whether or not an arrest was made, true or false. Again, we're using the $ here just to extract a single column. Or we can compute crosstabs by adding a second column. So what were arrests like by the different groups? Okay, we can produce summary statistics with the summary function. That's pretty cool. So we'll get 6 number summaries, minimum and maximum, first and third quartile boundary, median and mean, for quantitative variables. And we'll get frequencies for factors. But look at all this character data. Maybe these should be factors instead. So one thing you can do when you import your data set, if you use the button, check the strings as factors box. This will convert all the character strings to factors. Alternatively, you can hard code it when you import the data with read.csv using strings as factors equals true. What does strings as factors equal true do? Well, let's look at the help file. So here we're at the help for read.csv. And we scroll all the way down to strings as factors. A lot of stuff we can do here. Logical. So if it's logical, you know, true and false are your only options. Should character vectors be converted to factors? True is yes, false is no. So now when we rerun summary, we will see that we actually get frequencies. Ah, it didn't work. Oh, because I didn't subset it. Now I got to subset it and then I can read it. All right, so now we get frequencies for those character variables. All right, we can use various functions to get more summary statistics. So we can use describe by to get summary statistics by a group like SICSS. So if we wanted to look at how data difference between males and females, we get a nice output like this. Yeah, Susanna, I know I'm going a little fast here. At which part?
You said you subset it? Oh, okay.
Yeah, so for cleaning, we just wanted these particular columns just to make it a little more manageable. Yep, so we're still using our bracket notation here. Right, so Mesa was the raw data. And then we just passed in the names of these 7 or 8 columns we wanted. Right, and then from there we can say, well, what's the distribution of age like, right? So now we're kind of getting into this workflow aspect. We can change the number of breaks. We'll talk about this more tomorrow. We can include title, or we can make something that looks kind of publication ready-ish. Right, so these data are positively skewed. The tail goes off to the right. We could use box plots here, where we pass in a numeric variable, followed by a tilde, and then a categorical variable. It looks like males and females are around similar age distributions. Same thing with race. And then we can analyze the data maybe through a one-way ANOVA. And follow it up with a post hoc test to say, well, are white drivers pulled over less than other groups? And it looks like based on these data in Mesa for this time period, the answer would be yes. Then you can use your domain expertise to say why. So I know we're at time, you guys. I know it's been a long day. I'm sorry the end of this session was a bit fast, but remember to contact us. I'm happy to stick around for a little bit to answer questions. For you guys, review this last section and try to read through the section about saving your work. And then look at the last challenge here. Try to load up the Oakland data set that's also in the raw folder, and then just kind of repeat this process. It doesn't all have to make sense right now, but just try to go through it, try to kind of get familiar with this sort of outline, right? And we'll talk more about how the computational part fits into these workflows tomorrow when we do our deep dives. And we'll start tomorrow with a review of this challenge here, just to kind of reiterate this. So this has been wonderful. I hope you guys have had as much fun as Jose and I have had. Please go well, be well, treat each other well, play your guitar, stick it to the man and all that. We're going to stick around if you guys have questions. Go get some dinner, go take a break, go take a walk, and we look forward to seeing you tomorrow. Thank you so much for your time.
Thank you all for watching. For more information on SICSS-Howard Mathematica, visit our website, follow us on social media, and join our email list.